Hello and welcome to FSC iCalc's tutorial on analyzing a water supply. The first thing we want to do is open up our water supply page on iCalc. You will need to have a pro account in order to use Watersupply. If you don't have one right now, that's okay. You can get one for a month for free without entering your card information when you sign up. Go ahead and do that now if you haven't, and then meet me back here. So to work with a water supply app, we want to ensure we have adequate water supply to meet the sprinkler system demand. We will fill out a supply situation and then go through the three different options for demand calculation. The first demand situation we will use is Special Design Method, one of the three methods of NFPA 13 that are included in the applet. I'll enter 5% for estimated overage. This is to compensate for the overage generated over the entire design area. On K-factor, I'll put in 25.2 and we can have 12 sprinklers operating at 15 psi. From here, we begin working on demand. As you can see, there are several allowances we can have for losses. I'll add 250 for a rack system, 250 for our water curtain, then 100 and 150 on the inside and outside hoses respectively. All these factors add up to the reduction in water pressure available from water source due to added gallons. Next is more supply information, which is a simple flow test. I'll set our flow test available at site as 63 psi static to 58 psi residual with 1360 GPM flowing. This is the base of our water supply. A few more things for this analysis. Outlet elevation shows us how much pressure is lost from elevation. When you enter in the feet measurement, as soon as you tab out of it or click anywhere else on the page, this box will show you the psi lost from that elevation. Lastly, we have loss through backflow device and any other losses you may happen to have not listed. I'll set these to 4 and 0 respectively, then hit process data. Now we have our water supply analysis. This output works by going down the list of fixed losses one by one and subtracting them each from the flow and pressure measurements. This shows us how much pressure we have to start with at our desired flow rating and how much maximum flow available from the water supply at 20 psi. It then compares these figures to our fixed losses and tells us if we have enough pressure left for the friction loss through entire piping network. Sometimes there's only a little bit of pressure left, and it's up to you to use your best judgment on how much is enough. Our friction loss calculator can help narrow down your margin of error on this. Alright, now let's experiment with what else this applet can do. What if we don't have enough pressure? I'll change our flow test data to a much larger loss in pressure, let's say 20 psi. Hit process data, and sure enough, we're 36 psi short of our system demands. The applet will not only warn you that there isn't enough pressure, but it will also warn you if there's not enough flow. I'll go ahead and lower the flow on our flow test to simulate this, and sure enough, it will warn you that you need a water tank. Adding only a pump to this supply won't fix the problem, so the applet reminds you that you need this tank. As for your friction losses, you can use the friction loss applet, which I'll go over extensively in another video. For now, at least you can see that it can port your data from this water supply we just did. Lastly, let's go over the other demand calculations. Come back here to System Design Basis and let's select the Density Area method. This may be a bit more familiar to most people. I'll run 0.49 gallons per minute over square feet for our density, and then leave the operating area at 3,000. Estimated overage can stay at 15%, and then go ahead and hit process data again. As you can see, it still shows us that we don't have nearly enough pressure or flow. So let's go ahead and readjust that flow test back to a better theoretical situation, the original 59 residual psi and 1360 flow. That would allow us to have enough pressure and flow for this system. And sure enough, if you hit process data, you can see the applet shows you have 14.84 psi left. The last system design basis is manual entry. This is pretty boring, but it can be useful for some different demand situations. You simply enter in how much flow is needed, which you have derived via manual calculations. The rest of the applet works exactly the same otherwise. Alright, that's all for today's tutorial. I hope you found this video helpful. If you still have any questions, you can reach us by going to the contact page on the iCalc website or by emailing support@fscinc.com, and I'll leave those links in the description for you. Thanks for watching. Make sure to subscribe and check out our other videos.